These alphanumeric characters are represented in the form of zeros and ones. If that is the case, what is the range of values that can be represented in case of this? Let me consider the fixed point representation and how it can be used in different formats. The 2's complement number representation is very accurate and it is not an ambiguous. These number systems can be converted from one format to another format. Hello everyone, it is Dr. Ravikumar YB. Today we shall see the representation of numbers. What is the meaning of representation of numbers and how these numbers can be represented in different formats is a topic of discussion today. In this session, we shall see as to how we can represent different numbers. I am speaking about the different numbers. These numbers can be represented in different formats. That is also very important here. So let me take you into the details of it. Usually, the fixed point representation system is used to represent any integer type of numbers or any floating point type of numbers. But what is the difference between fixed point representation of numbers and floating point representation of numbers is a topic of discussion today. In this session, we state that computers usually represent the numbers in the form of binary format, which is very useful as it is very much accurate, precise and easy to store the data items in the computers. We use the binary form of the number representation. So, if that is the case, the alphanumeric characters, that is, alphanumeric characters means alphabets, characters, numerals, all these are called as alphanumeric characters. These alphanumeric characters are represented in the form of zeros and ones. How these alphabets are represented in the form of binary format and how these zeros, numerals are represented, alphabets are represented. If that is the case, A is the equivalent of this. Let me consider that the value of A is equal to 10 in hexadecimal value. If this is 10, this has to be converted into 1010 format and 0 is represented in the form of 0000 format and B is represented as 11, so 1011. So totally we will represent it in the form of this, that is AOB. A0B is equal to this format, A0B. So we have this format of a representation. So similarly, why we prefer to represent these numbers, that is alphanumerals in this format is, it is very easy to represent in the computers and very accurate, and the space required to store these numbers, that is the binary numbers, is very easy. So it is preferred over the alphanumeric characters. So if that is the case, we shall see there are various types of number representation system. That is, the first one is binary number system. Second one is decimal number system. Third one is octal number system. Fourth one is hexadecimal number system. So usually we represent the numbers in these formats, that is in binary number system format or decimal number system format, octal number system format or hexadecimal number system format. So these numbers can be represented in any of these formats, and there is a possibility to convert any number from binary form to decimal and decimal to binary. So we have these options here. Then again, binary to octal then octal to binary. Similarly, binary to hexadecimal, then hexadecimal to binary. So we have these possibilities to convert from one form of number representation to another form of representation so that the numbers can be represented in varying format. But the binary number system is most relevant and popular for representing the numbers in digital computer system, as it has got a very good advantage over other number systems. So we will prefer the binary number system over other types of number systems like this decimal, octal or hexadecimal number system. In the case of this, binary number systems usually vary from 0 to 1. That is, in case of decimal number system, the number varies from 0 to 9. In case of octal number system, the number varies from 0 to 8. Octal, or in this case 0 to 7 means 8. So let me represent it as 0 to 7. Fourth, hexadecimal number. That is 0 to 9, then A to F is used to represent the numbers. Hexadecimal. Hexadecimal includes 16 numbers, hexa. Octal means 8 numbers. Decimal. Deci means 10 numbers. That is 0 to 9. Then 0 and 1 means 2 numbers. Binary. Bi means 2 numbers. So this is how the number systems are represented, and these number systems can be converted from one format to another format. Now, there are structures for storing the real numbers, which is the first one, unsigned integer. Suppose if I have a value 10, I can store it as it is in this format, that is in unsigned integer format. Suppose if I have minus 10, then I have the decimal digit here as well as sign, which is indicating that it is a negative number. So it has to be represented in this format, signed integer format. Then unsigned fixed point format. What is the meaning of fixed point format? You can see that there is an integer part as well as fractional part. So 2.5000. I can represent it as 000 to 0.5000. That indicates that we have a fixed number of digits before the decimal point and fixed number of digits after the decimal point. So it is called as 2.5000. It is a positive number. Similarly, if it is a negative number, what has to be the value of that? Minus 0.000 to 0.5000. This is not 0 point, it is minus 0002.500. This indicates that this is the sign of this. This indicates the sign. This indicates the integer part. This indicates the fractional part. Then floating point numbers. How these floating point numbers can be represented? We can represent it with variable decimal part as well as variable fractional part. That is 2.536295. We can have variable number of length of the fractional part. So since it is a positive, I can represent it like this, and I can represent it in the form of this. Suppose if it is a positive number, I can represent it. If it is a negative number, minus 2.536295, this can also be represented in this format. Then variable length. What is the meaning of variable length? That is sign, size and digits. What is the sign? If it is minus, what is the size of that? The size is 2. How many digits are there? 5 digits are there. So this can be considered here as first bit is considered as sign, second bit is considered as length, and third bit is considered as the digit. So unsigned rational, this is used to represent the numerator and denominator part. That is the numerator, if I have 1 by 3, this is called as the numerator part, this is called as the denominator part. So I can use this unsigned rational. So similarly, if I have a signed rational format, then I have to represent it in the form of minus 1 by 3, where this indicates the sign of this and this indicates the numerator part and this indicates the denominator part. So totally we have these types of numbers which can be represented in these different formats. So if that is the case, we shall move forward and find out as to how we can represent the numbers. Basically, we represent these numbers in two different formats. One is fixed point notation and the other one is floating point notation. The floating point notation is going to be explained in the next session. Now in this session, let me consider the fixed point representation and how it can be used in different formats. That is the topic of discussion in today's session. Now in fixed point notation, there are fixed number of digits after the decimal point, whereas the floating point number allows for a varying number of digits after the decimal point. As I have already discussed with you, that is 0002.5000. We have only 4 digits after the decimal point in case of fixed point representation. Whereas in case of floating point representation, we will be having 2.539645, so on like that. This is called as floating point representation. This is called as the fixed point representation. This is called as a fixed point representation. This is called as a floating point representation. If that is the case, we shall move forward and find out the next one. Here, fixed point representation. For example, this indicates the number. The number which is prior to the decimal point is this. The number which is next to the decimal point is this. That is FFFF. Now, what is the minimum value that I can store here? The minimum value that I can store here is this. That is decimal point 0. That is 0000 point is the decimal point. And what is the minimum value I can store here in place of this F? 0001. This is the minimum value I can represent here. Similarly, what is the maximum value I can represent in case of fixed point representation? That is 1111 point. If you look at this, what is the value of 9 here? 9 is the maximum value. If that is the case, what is the meaning of 9 here? So here, if I represent it in the form of the maximum value, that is, this becomes 999.9999. That is, these places, these binary numbers are placed with 9999. That becomes the maximum value of a fixed point number representation system. Then we have unsigned fixed point number representation. In this case, we do not have any sign here. That is, if there is no sign, it is an indication that it is a plus. If there is a sign, then I must represent it in this format. That is signed fixed point representation with sign, integer and fractional part. If that is the case, I can represent it as minus 0.0001. This is called as the signed fixed point. If what the minimum signed fixed point. What is the maximum signed fixed point according to this? I'll place this as 9999.9999. What is that? I will include the minus sign here. If that is the case, I will call this as maximum fixed point numbers. So this is how we represent the signed as well as unsigned numbers. So if that is the case, what is the range of values that can be represented in case of this? If that is the case, I can represent it from here for signed numbers minus 2 to the power of k minus 1 minus 1 to 2 to the power of k minus 1 minus 1 for k bits. If that is the k is equal to 8, if k is equal to 8, then 8 bits, then what is the minimum value I can represent it here? Minus 2 to the power of 8 minus 1 minus 1 to 2 to the power of plus 2 to the power of 8 minus 1. That is this. This is the minimum value. This is the maximum value. That is minimum value. This is the maximum value. So minimum to maximum, what is the range we have here? If that is the case, 2 raised to the power of this can be written as 2 raised to the power of 7 minus 1 as the minimum value and 2 raised to the power of 7 as the maximum value. So if that is the case, 2 raised to the power of 7 is what? 2 raised to the power of 7 can be represented as 2 into 7 times 3. This is equal to what? Let me represent it. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64, 64 2s are 128. What is that? We have minus here. So 128 minus 1, that is minus 128 minus 1 within brackets to 128. What is the meaning of this? This has to be resolved first. If that is the case, minus 127 to 128. So this is the range of values I can represent it here. That means minus 127, minus 126, minus 125, minus 124, minus 123, minus 122, minus 121, so on like that till 0. After 0 we have 1, 2, 3, so on till 128. We have these numbers. So this is the range of numbers. I can represent it in the case of this signed representation. This signed representation varies from minus 127 to plus 128. That is why we represent it as k bits. For ones complement, what is the ones complement of that? If that is the case, I will represent any number, whether it is 128. If I consider it as a 128, what is the value of that? 128. This is 1, 2, 4, 8, 16, this position 32, this position 64, this position 128. So we have 1 in this position 128. How can I say that it is 128? How can I say that it is 64? How can I state that it is 32? We have a representation meaning here because 2 raised to the power of is 0. 2 raised to the power of 0 is what? 1. 2 raised to the power of 1 is what? 2. 2 raised to the power of 2 is what? We have 4. Similarly, 2 raised to the power of 3 is what? 8. 2 raised to the power of 4 is what? 16. 2 raised to the power of 5 is what? 32. 2 raised to the power of 6 is what? 64. 2 raised to the power of 7 is what? 128. So we have 2 raised to the power of 7. That is, in this position I have a value 1. If that is the case, I can represent the value 128 in this binary format. Right? So, if that is the case, if I represent it in the form of a 1's complement, what happens? This becomes 1 becomes 0, 0 becomes 1. This is called as the 1's complement of this number. Complement of this number. What about the 2's complement of this number? How can I represent it in the form of a 2's complement? Yes, I can represent it in the form of the 1's complement as well as 2's complement. How can I represent the number in terms of 2's complement? It is also very easy. If I add plus 1 to the 1's complement, I'll get the resultant which is in 2's complement. How can I represent it? That is this value plus 1. If I add plus 1, this becomes a 2's complement. If that is the case, I will consider here 0, 1, 1, 1, 1, 1, 1, 1. I will add 1 to it. What is the value we get? 1, 1 binary addition. 1, 1 it is 0, 1. This becomes 1. Again 1, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. This becomes this. Did I get the result of that? So 1's complement number can be represented, but at the same time we can also represent the numbers in the form of 2's complement. But what is the advantage of using the 2's complement over 1's complement? The 2's complement number representation is very accurate and it is not an ambiguous. That means there is no dilemma to represent any numbers ranging from minus 127 to plus 128. So that is the reason the systems usually represent the numbers in 2's complement format. That is the reason you are going to observe here. If that is the case, let us assume one example here to represent the fixed point representation. In this fixed point representation, we have 32-bit number format. In this case, we have 1 bit reserved for sign bit. And the next 15 bit is reserved for integer part. And then next 16 bits are reserved for fractional part. If that is the case, I can represent the number which is minus 42.625. I can split it. That is minus 43.625 can be split into two different parts. This is the integer part 43. We have another part that is, this is part 2. What is that? We have a sign here. This is part 1. I am just splitting the numbers into different parts. I have this part, fractional part. I will call this as 0.625. I will represent it as this in this format. So 0.625 is called as part 3. So the number can be represented in the form of this, that is minus 43.625. If that is the case, we have the numbers or the bits varying from 16, 0 to 16. That means 0 to 15. That is 16 bits is equal to 0 to 15. So including 0, that represents 16 bits positions. If that is the case, we have totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if that is the case, I can represent these numbers into the power of 2 raised to the power of 15. From 2 raised to the power of 0 to 2 raised to the power of 16. If that is the case, what happens? What is the 2 raised to the power of 0? It is 1. What is 2 raised to the power of 15? It is 32,768. You can calculate it. If you calculate it, if you multiply it 15 times, so on up to 15 times, you will get the value 32,768. So that is the value. I can represent it here after the decimal point. That is, in the fractional part, I can represent this as the maximum value in this case. That is in 32-bit format. That is minus 43.32768. This is the maximum value I can store here in case of this 32-bit format. What about the value? Suppose if I want to store minus 43.32,769, is it possible to store in our system in this 32-bit format? It is absolutely not possible, because the length of that varies from 0 to 2 to the power of 15, 2 to the power of 0 to 2 to the power of 15. What is the maximum value I can store here? I can store here only 32,768. That is the maximum value I can have in the fractional part. If that is the case, what is that? See here, what is the minimum value I can store here? That is 1. What is the maximum value I can store here? 32,768. That's why I'm representing it as minus 43.732768. In this case, specific case, what is the value I have? It is within the range of that. That is 0 to 32,768. So in the fractional part, we have 625, which is easily represented, which can be easily represented in our system. If that is the case, let me consider the value varying from 0 to 625. What is that 625 indicates in this case? Let me take up this. This is 2 raised to the power of 0, 2 raised to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 1 in the 13th place, that is 2 raised to the power of 13. We have 14, 15. What is that? 2 raised to the power of 15. What is the value we have here? If that is the case, but in this case, we are going to represent it from right to left, not from left to right. In this case, we have the value which is going to be represented from in this format, that is fractional part. If that is the case, see here, observe here, we have the value minus 43. What is that? Minus is indicated by plus 1 and plus 43. If we have the value 43.625, I can represent it in this form, that is 0. Everything remains same as it is in the integer part, and everything remains same in the fractional part. So we have 0 in place of this because I have a positive. If I do not have any sign here, that is called as a positive value. If I have a negative value, that is minus 43.625, then minus sign must be represented. How can I represent it? It has to be represented in the sign bit with 1. This indicates that the number is a negative number. If that is the case, what is the value of this? 2 raised to the power of 0, 2 raised to the power of 1, 2, 3, 2 raised to the power of 3, 4, 5, 2 raised to the power of 5. If that is the case, what is the value we have here? 2 raised to the power of 5 is 32. What is the value? 2 raised to the power of 3. 2 raised to the power of 3 is 8. What is the value? 2 raised to the power of 1 is 2. 2 raised to the power of 0 is what? 1. If I add up all these values, what is 32 plus 8? 40. 40 plus 2? 42. 42 plus 1? We have 43. Do I have the value 43 here? Yes, I have a 43 here. I have 1 here, so it is negative minus 43. Then I have 0.625. How can I represent the 625 here? In the same format. I can represent it in this form as, please don't forget it, it is not 2 to the power of 0. It is 1 divided by 2 to the power of 0. Because I have the values after this decimal point, not before the decimal point. If that is the case, this turns out to be 1 divided by 2 to the power of 1. This 1 divided by 2 to the power of 2. So on till here. If that is the case, we have 1 in the 2 to the power of 13. That is 1 by 2 to the power of 13 and 1 by 2 to the power of 15. That turns out to be the value which is equal to 0.625. If I add up all these parts, that is part 1, part 2, part 3, that becomes the value of this. The entire term which is representing the value minus 43.625. The same thing is explained here. So let me take you into the details of it. Here 0 is used to represent the positive and 1 is used to represent the negative numbers. So as I have already told you that we have 15-bit binary numbers, that is varying from here to here. 15 bits, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 bits here. These 15 bits can be used to represent the decimal part of that, that is the number 43. Suppose if I want to represent the fractional part, I have 16 bits to represent that. If that is the case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So totally we have 16 bits to represent the fractional part of a number. So if that is the case, the advantage of using the fixed point representation is performance is very good. But there is a disadvantage, that is the limited range of values that can be represented. That is the disadvantage of using this floating point representation. Other than that, it is very useful and very good to represent the numbers in any of these formats. Next, in this case, fixed point representation, we have the integer part which is of length 15 bits. We have 16 bits to represent the fractional part. We have 1 bit to represent the sign of that. That is, the smallest number that can be represented is 0. All 15 bits are 0 and all 15 bits are 0 in 16 bit and 1 bit, that is the last bit is 1. This is the minimum value I can represent it here in case of fixed point representation. Then what is the maximum value I can represent it here? That is sign part, that is 1 bit. This is 15 bits. All 15 bits are 1. And what is the maximum value? All 16 bits. All 16 bits are 1. That means what is the maximum value? That is the maximum value I can represent it in case of this fixed point representation. This is the smallest number I can represent it here. That is the minimum value. And this is the largest number I can represent it in case of this fixed point representation. If that is the case, we shall see how to represent these numbers. We have 2 raised to the power of minus 16. Please understand it very carefully. I used the word 1 by 2 raised to the power of 13, which is equal to 2 raised to the power of 13 is not same as 1 by 2 raised to the power of 13. I can represent it in this form as, this can also be represented as 2 raised to the power of minus 13. Right? If in the same format, we are going to show it, that is 1 by 2 raised to the power of 13 is 2 raised to the power of minus 13. If that is the case, we have the value that is 2 to the power of minus 16. What is that 2 to the power of minus 16? 2 to the power of 0. 2 to the power of, if I consider the next term, that is minus 15. 2 to the power of minus 14. Do I have this? Yes, I have these numbers in this. Here, 2 to the power of minus 15, 2 to the power of minus 14, 2 to the power of minus 13, 2 to the power of minus 12, 2 to the power of minus 11, 2 to the power of minus 10, so on up to 2 to the power of minus 2, 2 to the power of minus 1, 2 to the power of 0. I can represent it as 2 to the power of minus 0. That can also be represented as 1 by 1, that is 1. 2 to the power of minus 1, 2 to the power of 0 is what? 1. That is a to the power of 0 is what? 1. So if I represent 1 by 2 raised to the power of 0, what is the meaning of that? 1 by 1 always leads to 1. The same thing is used here. If that is the case, we have the value varying from 2 raised to the power of minus 16. That is the approximate largest positive number I can store here. And which is that? 2 to the power of minus 15 plus 1 minus 2 to the power of minus 16, which is equal to 32,768. And a gap between these numbers is 2 to the power of minus 16. Please try to understand here. What is the gap between one number and the other number? The one number and the other number is this. That is, we have 2 to the power of 15. If I add up all these values, that is 2 to the power of 15, 2 to the power of 14, 2 to the power of 13, so on till 2 to the power of 0. If I add up all these terms, what is the value I get? I get the value which is equal to 32,768. So if that is the case, what is the gap between this number to this number? What is the gap between them? That has to be represented in the form of a fractional part, that is 2 raised to the power of minus 16. What is the meaning of 2 raised to the power of minus 16? I can represent it as 1 by 2 raised to the power of 16. If that is the case, I can represent it as 1 by 2 raised to the power of 16, that is in the form of fractional part. So on like that. So that is the minimum value, that is the distance between one number and the other number system. We can move the radix point either towards the left or towards the right to help the integer field is 1. That is the only thing we have in case of fixed point representation of numbers. So, in this session you learnt about the fixed point representation of numbers. In the next session you are going to learn about the floating point representation of numbers. You will see the difference between the representation of numbers in the fixed point as well as in the floating point. That is going to be explained in the next session. Thank you very much. Thank you all.